ellipse.
What is the point in the plane such that the sum of the distances from 2 to 1?
So set of all points in a plane where the sum of the distances from 2 points is the same. Sum of distances from 2 points is constant. So I'm going to do a circle up here. Since a circle is basically if you collapse all those points, they are plus the 2 points into a single point. Circle, set of all points in a plane such that they are equidistant from a single. From single point. Now, for actually drawing an ellipse, if you want to do it using the definition, we're going to do that up here on the board. So in general, an ellipse looks something like this. And you'll have 2 points. What are they called? Foci, or focus. A single focus is singular, or if you want plural, is foci, or foci. Yep. Also have a point here. What would that one be? Center. Okay. And some important part, going across here, this is going to be your major axis. And the other direction is your minor axis. And notice these are lines, they are infinite in length, so it doesn't matter if I extend it outside. I just extend it so you can see the labels there. Now on the circle, we've got some other important points. A vertex. Here and here. And your co-vertex. Now some distance measurements. This right here is B, and this right here would be B as well. Yes, they're both B, so yes. This part here, A, and that would be A. And this measurement, C.
Is that a co-vertex? Is that what you're talking about?
Yeah, co-vertex is another co-vertex. So 2 co-vertices. And if this was a vertical one, all you have to do is turn your head sideways. C is the distance from your center to your focus.
Is the green one the minor axis?
Yes. No. 2C equals A? No. Because no, A goes all the way to the vertex, and C does not go to your vertex. And this is not necessarily twice the distance. Now, we're going to do a chart like we did yesterday with the parabola. This chart has a few more things on it. So for ellipses, first 2 things, 2 equations which apply for all of them. C squared is equal to A squared minus B squared. And second one, A is greater than B. And notice A, B, and C are always positive. Because we're saying they're the distance from the different points. So now, horizontal and vertical. First one, your equation. Does that look familiar? Yeah, A squared here and B squared here. What's the difference between these two? Okay. A squared and B squared are swapped. So, which one is bigger, A squared or B squared? A squared is always bigger because A is greater than B. Which means that just looking at this, you can look at any ellipse and say, is it vertical or horizontal if it's in this form, because wherever the bigger number is, that one tells you whether it's vertical or horizontal. So we have to say x minus 4 squared over 12 plus y minus 7 squared over 16 equals 1. Is this vertical or horizontal? Vertical, because the bigger number is under the y. If this was, say, 35, it is horizontal because the bigger number is under the x. So when you look at it, since A is bigger, then if you look at this one, the bigger number is under x, it's horizontal, bigger number under y, it is vertical.
How do we write that?
What?
How do we write that in those together?
I don't know.
Wait, so x is bigger on the horizontal
If the number is bigger under the x, then it's a horizontal one. If the number is bigger under the y, so if A squared is bigger than B squared, okay, your sketch. Oops, I think I forgot one more equation up here. I'm going to put it up here. C is equal to, or not C, E equals C over A, where E is eccentricity. So a simple sketch, this one, just something like that, and here's something like this. And your vertices. Let's do center first. Center. Where's the center of this?
In the center?
What would the coordinates be given that you have this equation?
0, 0.
Okay. Does that look familiar? Same format as we had when we were dealing with the parabolas. H comma k and H comma k. Then we're going to talk about the vertices. So how far are the vertices from the center? A unit. If it's a horizontal one, where are they changed, vertically or horizontally? From the center. Horizontally. So we're going to have H plus or minus A comma K. So you have one at plus A, one at minus A from the center. For vertical, what is it going to do?
H, K, minus A.
So H comma K plus or minus A. So your covertices, what will be? Okay, so Because we're going straight up and down vertically to get to the two vertices. Over here, h plus or minus b, comma k. Does that make sense? Everybody see where we're at? Next we'll do foci. Notice foci is plural of focus. Just like vertices is plural of vertex. So where are the foci going to be? Okay, h plus or minus c, comma k. Remember, you're going from your center. Your vertices would, or your foci would be c and it's left or right of it. And over here, h comma k plus or minus c. So I'm going to put here, we're going to say, what is the equation for the major axis? And here, what's the length of the major axis? What is the length of the major axis first? Or from vertex to vertex? 2a. Over here? 2a still.
Oh, 2a.
Because remember, A is still talking about your major axis. And where is that located at? Yeah, y equals k. And over here? X equals h. Minor axis. Okay, where's it going to be? Okay, opposite. So x equals h, y equals k, and what's the length?
2b.
2b, or not 2b. So, there is all the stuff for an ellipse. Things with circles are much easier. That's the next one. Circle. Got three things. And most of you should have seen in at least geometry. First, your equation. X minus h squared plus y minus k squared equals r squared. That look familiar? Like what many of you did use that when you were doing your project. Sketch. What does a sketch of a circle look like? Yeah, I succeeded. Close. Anyway. Where's the center going to be? Where's it going to be though? What's the coordinate of the center? HK. And your radius, what is it? Given this equation, r. Okay, so everybody follow those. That's it for the circle. Second unit page. Have we got what they need? Okay. Okay, so, what shape is it? Is it a parabola or ellipse? Or circle?
Circle.
Okay, let's test it, see how we do it. So, we're going to have to complete the square twice now for this one.
Why?
You have to complete the square with the x's and with the y's. So, x squared minus 8x, I'm going to put that here. And we're going to have to add something. Y squared minus 6y plus something equals 39.
Can I write this down?
As an example, there's some problems in your book that are like this. You can do it or you can choose to or not to. So what number is going to have to be added here? Make this a perfect square number. 16, sir? How do you get 16? 8 divided by 2 is squared, so we know this is going to be 16 over here, 9. Now I can't just add these at random, I have to also add them over here. What is this going to factor out? Okay, x minus 4 squared plus y minus 3 squared equals, and what are we going to add these all? 64. Go.
On the second line, what goes into 16 and y squared?
Oh, this should be a plus. Because it was a positive y squared. So, where's the center of this? Is 4 comma 3. What's the radius? 8. Okay, everybody follow what we did there? Yes, okay.
So when the book asks us to describe a circle, we only
Yeah. Basically, the definition of a circle tells us we need a center and we need the radius. The definition says the center of all points equidistant from a certain point. If we know what that certain point is and we know how far we're going, that's all we need to be able to describe it. Let's see. Another type of one. Let's see. Where do I want? A bit harder than that one. Okay. So x squared plus 4y squared minus 6x minus 7 equals 0. What shape is this? Okay, how can you tell? Okay. So, notice in this one, these two were the same number. They both have the same coefficient, which recognize that you should recognize that as a circle.
What?
X squared and y squared both have the same coefficient, which guarantees that you're going to have a circle.
It's question 1.
Yeah, 1. If you look over here, x squared and y squared do not have the same coefficient, which means it's not going to be a circle. It can't be a circle if they don't have the same coefficient, unless there's some other math going on. Like, for example, if you had a minus 3x squared over here that was added together to the thing. So, let's do complete the square again. With the x. So x squared minus 6x. What do we need? Plus 9. Plus 4y squared minus, okay, equals 7 plus 9. Yes, with that. So what is this going to factor as? Okay, 7 plus 9 is 16. Okay, now since we know it's an ellipse, what do we need to have on the right-hand side? 1. So how am I going to get 1?
Yeah.
You could get it by subtracting 15, however, that won't fit us our formula.
Right.
Divide by 16. So we're going to have x minus 3 squared over 16 plus y squared over 4 equals 1. So is this vertical or horizontal? Okay. Horizontal. Where's the center? 3, 0. Where are your vertices? And so let's do what is A equal to? 4. What's B? And what's C? Remember we had C squared equals A squared minus B squared. 16 equals, or not 16, C squared equals 16 minus 4. Square root of 12, which is 2 root 3. Once we have all those, it's really easy to plug in and get all the rest of the stuff, right? So, vertices. What do you have?
What's 3, 0, is that the center?
Yeah, the center, sorry, it's just not labeled. Okay, and how do you get that? Yeah, so 7, comma, 0, and where's the other one? And 1, 0. So I'm going to do a sketch just because it helps me visualize stuff. We said the horizontal, 3 zeros in my center, so somewhere over here. So it's going to be something like this. And so we know our vertex, we're going to have one vertex over here, one vertex over here. So 7, 0, negative 1, 0. Co-vertex. And? Yeah. Foci. So I'm going to write 3 plus or minus 2 root 3, 0. Now, why do I write this one this way or the other way? Because this is irrational and makes it a bit messy. I mean, we could write this as 3 plus root 2 root 3 over 0 and 3 minus 2 root 3. But since we're not simplifying it, it looks better to combine it into a single expression.
Do we have to graph it at all?
Yeah.
So how would we graph it without knowing the exact profile?
Okay, so do you do the rest of those? Or do you look at some graphs?
Did you do the rest?
Oh, we don't have a lot of time.
Oh, never mind.
But we can, I mean, everybody can see once you have A, B, C,
Yeah.
it's easy to get all the rest of the numbers.
Mm.
Okay, I didn't talk about what eccentricity meant. Right. When we talk about eccentricity, we're saying how close to a circle is it? So this would have a eccentricity. Notice, what is the formula for eccentricity? C over A. And notice, C is your distance to your focus. See, if your foci are really close together and this distance is A, what's going to happen?
It's going to be small.
It's going to go to 0. This is going to 0. So a circle has an eccentricity of 0. Whereas if we did something like this, your foci would be somewhere way out here. So what's the ratio of C to A? What's it going to? Well, if this was, say, 10, if this is 12, it'd be like 5.6, or 87, or 0.87. So as you get more and more flattened or non-circular, it goes closer and closer to 1. So eccentricity of 1 is actually would be a straight line. And it wouldn't really be any lift anymore. It would be like the closer you are to a 1, the closer you are to a flatter. Like you get 0.999, you get a ellipse that looks something like, let's see, this. Still follows the same rules, however, you can get very extreme.
Does it always...
It could be vertical too.
What's the eccentricity of the 10 and 12 one?
So this one would be what 10 divided by 12. So 0.87 or 86666, I think. So it's basically take C, distance to your focus, divided by distance to your vertex.
So it should be decimal sign this.
Yeah, it's always going to be, it's always a decimal.
The first it was always 0.
Well, for a circle, you don't really talk about eccentricity because it's not eccentric at all. Okay, so graphing. What I expect, let's see, x minus 2 over 4 plus y minus 1 squared over 9 equals 1. So, first, where's the center? 2, 1. So you don't necessarily need to mark it, however I like to mark it so I know where I'm measuring from. And the easy thing, how is this vertical or horizontal? Okay, it's vertical. What is A? 3. So from this point, I can go up 3 spaces. 1, 2, 3. There's a vertex. 1, 2, 3. There's another vertex. What's B? 2. So that's the square root of 4. I can put my co-vertices on here. 1 there and there. Once I have those, what I generally do is do an approximate sketch. Top one, something like along those lines. Try to get it rounded.
Is that all you need to do to graph it?
Yeah. I'm trying to get it nicely rounded around. That's pretty good. Now, if you turn stuff like this, which I have seen people do, okay, in case you're in doubt, that is not in the list. Yes. So, try to make it look nice. Try to get it as curved as you can. That's your goal with something like that.